What is up, ladies and gentlemen? Welcome to day 89 of Fusion. Man, this is fun. I was finally doing some late night tinkering and actually got a Geneva Gear to work. Now, one thing that kind of hit me when I was making this is that is Geneva considered a gear or is it more of a cam? I think an argument can be made kind of both ways, but I'm willing to bet there's a technical engineering term. If you know, throw it down in the comment section. I'd love to hear your argument for it. But in any case, we have gone quite a ways, folks. Did you notice the intro video? Super fun. If you notice, I have a new camera and microphone, so hopefully this video quality is better than some of my rougher videos. Thank you for being patient with me through that. But in any case, we're going to make a Geneva Gear. Before we do that, there is one thing I'm going to kind of bring up, and that is this program right here. So the problem with making a Geneva Gear is that the relationships in there are very complicated. But, and I kind of like ruined my own little surprise here, is that with this website, and I'll put it down in the comment section below, but where you can get this website will do the calculations for you to make your Geneva drive. What I find really, really interesting is that Pythagorean theorem is in a Geneva Gear or Geneva Cam, whatever it is. In any case, Pythagorean's theorem is true, and I just find that I was really floored by that moment. Super nerdy, but I just find that is absolutely interesting that Pythagorean's theorem is applied here. So the cool part about this is that we can define a couple variables when it comes to our gear. We can define A or B in Pythagorean's theorem, the number of positions that it has, and how thick a pin is with allowable clearance, and it will calculate the rest of it for us. It will go ahead and animate this for you. I'm going to show you what it should look like when we create this successfully. So what I'm going to do now is I'm going to take this window and I'm going to drag it off to the side so you can't see it, and we're going to build this gear. Now, why would we want to use contact sets rather than joint or motion links is because this is considered a non-linear relationship. So what we're going to do is we're going to create a sketch. We're going to create all this, but we're actually not going to use joint links here. We are, however, we're going to draw this out. So we have two circles overall. We got the Geneva and the driven gear. We're going to go throw in some dimensions. The dimensions for B, my Geneva wheel overall, is 1.7321 for the radius, but we're going to times that by 2. And for drive crank radius is 1 inch, so we're going to make that 2. The dimension between these two is going to be your C, your Pythagorean. Oh, that's just so cool. Your C, which is going to be 2 inches. And from here, we're going to start to do some other things as well. What I am going to do is go ahead and move these dimensions kind of out of the way because it's going to get a little cluttered in here. It gets a little crazy. And I want to keep this kind of organized as much as possible, but I'm still going to try to do this all in one sketch. We do want a center axle to go through both of these. That way we have something for these to revolve around. And we're going to create a couple different components from there. Next thing I'm going to do is I'm going to create my slot. So we're going to click on Create, Slot, Center to Center Slot. And I'm going to go from the very top of my circle and we're going to go on down. Now my slot length is going to be 0.3721, so 0.7321. And my slot width is going to be 0.3. Okay, I'm going to go ahead and hit T for trim. We're going to trim up some of this. And we are going to then also draw a circle. I guess I'll take that a step back. Let's do a circular pattern of the slot. So we're going to go ahead and do this U-shaped geometry around this center point. Oh, hold on. deselect that center point. Let's center point and then select the center point. There we go. There we go. Bump it up. I'm going to go ahead and do 6 and then hit OK. Now I'm going to go ahead and T for trim. I noticed we already did something wrong, but it's okay. We can just fix that dimension here in a second. Okay. This already looks funky. This isn't even overlapped well. Well, that's because the value it gives you here is where the pin is going to stick up through, not the diameter of the actual wheel. So we do need this to be bigger. I'm going to go ahead and make that, 4 looks a little big. Let's do 3. I just need to be big enough to fully and completely cover these pin slots. Okay, I will now draw another circle. Right click, make it a construction circle, and give it a dimension of what we had earlier for a value. That's going to be 2. So what we see right now is that this circle overlaps through the center of the slot paths, means everything's looking great. I'm going to hit C for circle. I'm going to draw on that to draw my slot for my pin for my slot, and our pin is 0.25. Okay. I believe we have almost everything we need for our sketch, except for one tiny piece. I'm going to put that tiny piece in later, so let's see if this works for now before we get too far into it. So I'm going to go ahead and click Finish Sketch. I'm going to rotate this down a little bit, and everything kind of looks good. I'm going to hit E for Extrude. We're going to go ahead and extrude these 2 pins out. Actually, you know what? Let's do them individually, because I want to go one to go up. We'll do as a new component. Bring that sketch on back. We're going to extrude this one down as a new component. And I'm going to rename these. Let's just call Axle. Axle 1, Axle 2. Hit E for Extrude. We're going to go ahead and bring this profile on up and make it as a new component. Looking good so far. Click OK. And then we're going to go ahead, E for Extrude, and we're going to bring the rest of that profile down. Make that a new component. Oh, I forgot to click that one last little piece in there. Let's fix that. And then E for Extrude. Let's go ahead and bring this last little peg up. And make that a join, because we want this peg to be part of this bottom cam down here. Alrighty, let's see how this works so far. I'm going to make that sketch inactive because it's kind of in my way now and make things a little blurry. So let's do a joint. Let's have, before I do joint, I always like to skip this step. I'm going to go right click to my axles and we're going to ground them. Make sure they cannot move. Now let's click on joint. Let's do the center of those 2 objects. That looks like it rotates correctly. Looking good. And then we're going to click join again. Do the center of those 2 objects, and that looks like it rotates correctly. Click OK. Now at this point, I'm curious if we're going to run into any issues. Let's see. Let's turn on enable all contact sets. So that means none of these pieces can run into each other, and I should be able to rotate this all the way around. Now where we might run into a little bit of issues is if you created too much of a tolerance or not enough of a tolerance. Fusion might start to cry on you, and the contact sets are like, whoa, 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 that's too tight of a fit. But this is looking pretty good. Now, what we are going to do in here is we're going to try to see if we can get that last little circular piece in there to fit correctly. let's try it out. So what I'm going to do is I'm going to go back to my sketch. Let's double click on the sketch. Let's zoom in over here and let's draw another circle. This circle is going to be where the clearance kind of resets for the peg. Let's draw a line. Let's cut this. This is going to be opposite of our peg, so I'm just going to draw a line across my circle there and trim this line up. Let's see if that works. I don't know if it will. What we're going to do here is we're kind of going big brain with it. Let's go back. Let's go into this extrusion right here, and let's deselect these two pieces. I think this is going to work. Let's see. Oh, it'd be so cool if it did. Okay. And let's go in here and let's for the peg, let's also select these pieces. Now, we haven't done the full rotate. We haven't fixed this. I'm just testing to see if this will work. Oh, that looks beautiful, folks. So all we need to do now is to take this and rotate it all the way through. That's just one little thing. Let's go back to our sketch and let's fix it. So I'm going to double click on the sketch and we're going to go to circular pattern. We're going to take this arc right here, rotate it around that center point, and we're going to do that 6 times. Click OK. We can trim this up if you really want to, if that's bugging you. But that puts in all of my little pieces. That looks great. Let's go ahead and clean those up just a little bit more. Oh, this is so much fun. There's my Geneva Gear in its full entirety. Hit finish sketch. C'est magnifique, it's great. Oh, look at that, folks. We made a Geneva Gear using the calculator we found online. If I animate the model, are we going to work? Oh, it's crying a little bit. Oh, because silly me, I was doing the wrong gear, or the wrong joint. Let's animate that side. That way the driven cam can affect the thing it's supposed to. Looks wonderful. Alright guys, hopefully this video has been fun for you. I'm looking forward to making some other videos kind of here soon that kind of get at stuff like this. It would be really fun to build, maybe even fun to 3D print and kind of have as showcase examples in the classroom. What I would like to do long term is kind of have a pegboard system of all these different gear interactions rather than just pictures. They can actually go up and turn a crank and actually see these in action. But I'm going to call this video done. You guys have been awesome. Stay awesome. If you like this, please like and subscribe. It has been tons of fun. We're going to keep making it, and I'd love for you to stick around. If you want to help, feel free to reach out. Until then, I'll see you guys in the next video.